Welcome to the Linux Commands and Shell Scripting course. In this course, you will explore Linux and the most commonly used shell commands. You will recognize that shell is a robust user interface for Linux and Unix-like operating systems. It can run applications and interpret commands. It also enables access and interactivity with files, utilities, and applications. You'll also learn how to write shell scripts to automate tasks, execute batch operations, and quickly construct useful programs. This course has 4 instructors: Ramesh Sanareddy, Rav Ahuja, Sam Prokupchuk, and Jeff Grossman. Ramesh Sanareddy is a seasoned subject matter expert with SkillUp Technologies. Rav Ahuja is a global program director at IBM and the architect for several IBM professional certificates. Sam Prokupchuk is a data scientist and software developer at IBM. And Jeff Grossman is a data science engineer and founder of 617 Data Solutions. Learning Linux commands and shell scripting, Bash in particular, makes you versatile. If you're a software developer, data scientist, data engineer, systems administrator, DevOps professional, system architect, or software engineer, a good understanding of Bash commands will enable you to write scripts that simplify the building process of all sorts of data pipelines and application workflows. We'll start off with an introduction to Linux. You will learn about the origins of Unix and Linux, the architecture of Linux distro, and how to accomplish simple tasks in a Linux terminal. The task of managing files and directories is crucial. You will learn how to navigate your file system and manage your files and directories by creating new directories, removing unwanted directories, creating new files, and copying and moving files and directories. You will learn how to view the content of your files in various ways. You will get hands-on experience with archiving the files and directories in a directory tree, extracting files and folders from your archives, and extracting and decompressing files from zipped archives. Script is a list of commands interpreted by a scripting language. It is widely used to automate processes. As we proceed, you'll explore all aspects of scripts and Bash shell scripting, what shell scripting is used for, and how to create and run your own shell scripts. You will also discover useful features of the Bash shell along the way, including the use of meta characters, input and output redirection, and passing arguments specified on the command line to your shell scripts. Finally, you'll put your newly acquired knowledge to test by finishing a practical project that requires using several Linux commands and creating a shell script. To get the most from this course, watch every video and check your learning by taking the quizzes. Use the discussion forums to connect with your peers and the teaching assistants. And most importantly, make sure you complete the hands-on labs to practice your new skills and demonstrate your abilities. Congratulations on beginning the next step of this exciting journey, and good luck!
Welcome to Introduction to Linux and Unix. After watching this video, you will be able to explain what an operating system or OS is, describe the origins of Linux and Unix, and list some of the features of Linux and Unix. What is an operating system? Well, it's software that manages computer hardware and resources and allows interaction with hardware to perform useful tasks. So, what is Unix? It's actually a family of operating systems. Some popular Unix-based operating systems include Oracle Solaris and OpenSolaris, FreeBSD, HP UX, IBM AIX, and Apple macOS, which is one of the most popular desktop operating systems today. In the 1960s, the original Unix OS was created at AT&T Bell Labs. However, like many operating systems at the time, it was made for a specific hardware system, in this case the PDP-7 computer. In the 1970s, the Unix OS was rewritten in C, distinguishing itself from other systems and making it portable to many hardware architectures. And then, in the late 1970s, UC Berkeley developed Berkeley Software Distribution, or BSD, an add-on to Unix providing additional software and capabilities. The famous Mac OS was later derived from BSD. So, what is Linux? Linux is a family of Unix-like operating systems. However, when referring to Linux, people are usually talking about a specific distribution or flavor. Linux was developed as an effort to create a free open-source version of the Unix OS. Key Linux features include the following. Linux is free and open source, which means anyone can view the source code. And with so many eyes on the source code, Linux has become the most secure OS over the years. It's multi-user. Linux is designed to support multiple users accessing the system simultaneously. It also supports multitasking, running multiple jobs and applications at the same time. And it's portable. Linux has been ported to run on many different types of devices and hardware platforms, from desktops to servers to appliances. How did Linux start? In the 1980s, GNU was developed at MIT. GNU stands for GNU's Not Unix and was made as a free open source set of the existing Unix system tools. And in 1991, Linus Torvalds developed a free open source version of the Unix kernel called Linux. The kernel is the core component of an OS that enables components to communicate with the machine's hardware. Here is Linus Torvalds' famous post, where he shared his progress making his own open source Unix-like kernel. He references Minix, which was another Unix-like kernel at the time. Soon after, in 1992, the potential of unifying GNU and the Linux kernel was realized as popular Linux operating systems began to appear. And in 1996, a computer scientist named Larry Ewing created Tux the Penguin, which was later adopted by Linus Torvalds as the official Linux mascot. Today, the BSD-based Mac OS runs on millions of devices across the world. Billions of Linux instances run on servers, serving us the modern web. And especially among developers, modern Linux operating systems such as Ubuntu are beginning to gain popularity in the PC space. Okay, well, what are the most common use cases for Linux today? First, it's used in billions of smartphones around the world via the Android operating system, which uses a Linux-based kernel. Linux is also widely used in supercomputers, where many Linux-powered servers are clustered together for high-performance computing applications. Enterprise and cloud data centers also use Linux over millions of servers running all kinds of applications, web servers, databases, and so on. And finally, versions of Linux can easily be used as your PC's operating system. Many people install Linux today as a learning experience or as their daily driver. In this video, you learned that Unix is a family of operating systems dating from the 1960s. Linux was originally developed in the 1980s as a free open source alternative to Unix. Linux Welcome to Linux Distributions. After watching this video, you will be able to describe what a Linux distribution is, differentiate between some common Linux distributions, and identify the use cases of some popular Linux distributions. So, what is a Linux distribution? A Linux distribution is a specific flavor of the Linux operating system. It may also be referred to as a distro. All Linux distributions must use the Linux kernel. This is the core component of the Linux operating system that enables the system to properly use the computer's hardware. And today, there are hundreds of Linux distros, each tailored for a specific audience or task. Okay, so what differentiates Linux distros from each other? Each Linux distro includes a unique set of default utilities that are part of the operating system, such as commands and applications that come pre-packaged with the distribution. Each distro has its own graphical user interface, or GUI, that you use to interact with the operating system. Each distro supports a specific set of commands that you can use in a shell, a window for entering and receiving output from commands. And lastly, each distro provides differing levels of support. It could be developed and managed as a community-backed project or maintained by a commercial enterprise. And it could be a long-term support version, or LTS, or a rolling release, where stable package updates are released on a rolling schedule. Debian is one of the earliest rooted distros, with the first release in 1993 named version 0.01 and the first official stable release in 1996, version 1.1. It is known for being stable, reliable, and fully open source. It supports many computer architectures or types of hardware. These features result in Debian being highly regarded in the server space. And furthermore, Debian is the largest community-run distro currently available. Another popular distro is Ubuntu. This is also an early rooted distro with its first official release in 2004. Ubuntu is Debian-based, meaning that it's built on top of Debian and uses a lot of the same tools as Debian OS. Ubuntu is developed and managed by Canonical, and Ubuntu has 3 official editions: Desktop for personal computers, laptops, and workstations, Server for simple file servers or multi-node clouds, and Core for the Internet of Things. Red Hat Linux, like Debian, is a core Linux distro, meaning that it is not derived from another Linux distro. Red Hat is known for being stable, reliable, and fully open source. It's managed by Red Hat, an IBM subsidiary. Today, it ships as Red Hat Enterprise Linux, or RHEL, an edition focused entirely on enterprise customers. Next is Fedora, which is known as a stable operating system that supports many architectures. It's also very reliable and secure, offering unique firewall and security features. It's actively developed with a large and growing community, and it's sponsored by Red Hat. Consequently, Red Hat uses much of Fedora's codebase, after testing of course. Another Linux distro is SUSE Linux Enterprise. Also known as SLE, SUSE Linux Enterprise is available in two editions, Server or SLES and Desktop or SLED. It supports many architectures, such as ARM for Raspberry Pi, and uses the SUSE Package Hub, which enables users to install packages that aren't officially part of SLE. And it's maintained by the small German open-source software company, SUSE. And finally, we have Arch Linux. The unique do-it-yourself approach of Arch Linux allows users to customize every part of their system. This makes it highly configurable, a freedom that makes Arch very popular. But it also means that you need a strong understanding of Linux and system tools in order to use Arch effectively. And because Arch isn't focused on stability in the same way as other distros, it has easy access to the newest software, which has little guarantee of being completely stable. In this video, you learned that Linux distros can be differentiated by their user interfaces, their shell applications, and how the operating
Welcome to Overview of Linux Architecture. After watching this video, you'll be able to list the layers of a Linux system, explain the roles of each layer in a Linux system, and describe the Linux file system. The Linux system comprises 5 distinct layers. The outermost layer of the Linux architecture is the UI, or user interface, which allows users to interact with the system using a keyboard or mouse. The application layer includes system daemons, shells, user apps, and tools used to perform tasks in a Linux system. The applications communicate with the operating system to perform tasks. The OS is responsible for jobs that are vital for system stability, such as job scheduling and keeping track of time. All Linux operating systems are built on top of the Linux kernel, which performs the most vital lower-level jobs. The kernel is the core component of the operating system and is responsible for managing memory, processing, and security. The kernel interacts with the hardware layer, which includes all the physical or electronic devices in the computer, such as processors, memory modules, input devices, and storage. The first layer in a Linux system is the user interface. The UI allows users to perform tasks by controlling applications with the keyboard. Desktop versions of Linux include a graphical user interface, or GUI layer, which is similar to Microsoft Windows. This extends the UI functionality to other control devices, such as a mouse. You might use a Linux machine to use a web browser to send your friend an email, or use a music player to listen to your favorite song. Applications are the software that enables a user to perform a task in a Linux system. Applications can include the following: system tools, such as compilers, programming languages, shells, which are special applications that are often part of the operating system itself, and user apps, which can be any kind of applications from browsers to text editors to games. The operating system controls the jobs and programs that are vital to system health and stability. Its functions also include assigning software to users, detecting errors and implementing measures to prevent complete system failures, and performing file management. In a Linux system, the operating system is built on top of the Linux kernel, which performs the most vital operations. The kernel is the lowest level software in a Linux system and has complete control of the system. It starts as soon as your computer boots and remains in your computer's memory while the system is running. It also acts as a bridge between your apps and your machine hardware, enabling the two to communicate effectively using system calls. The kernel has 4 key jobs: memory management, process management, managing device drivers for proper hardware support, and assuring the system remains secure. The final layer in the Linux system is the hardware, consisting of the physical or electronic devices that make up your computer. This layer can include the following: the Central Processing Unit, or CPU, which is responsible for executing most calculations; the Random Access Memory, or RAM, which is a fast storage unit used to hold the temporary information your applications need to run; storage for data that needs to persist when your computer is powered off; your computer's screen; and any USB devices such as a keyboard, mouse, or USB drive. The Linux file system is the collection of files on your machine. It includes the files needed to run the machine and applications, as well as your own files containing your work. The top level of your file system is the root directory, symbolized by a /. Below this is a tree-like structure in the directories and files in the system, and the file system assigns appropriate access rights to the directories and files. The very top of the Linux file system is the root directory, which contains many other directories and files. One of the key directories is /bin, which contains user binary files. Binary files contain the code your machine reads to run programs and execute commands. It's called /bin to signify that it exists directly below the root directory. Other key directories include /user, which contains user programs, /home CD or USB drives that are connected to the system. There are several other directories in the root directory, but you will not need to access them during this course. All the files and directories in a Linux system are organized into one of these designated folders, depending on the purpose of the file or directory. In this video, you learned that a Linux system consists of 5 key layers. The user interface is the layer.
Welcome to Linux Terminal Overview. After watching this video, you will be able to describe what the Linux shell is, describe what a Linux terminal is, explain how a Linux terminal and shell work together, and use a Linux terminal to navigate directories. The Linux shell is an OS-level application that interprets commands. In early versions of Unix and Linux, the shell was the only way to interact with the operating system. Today, you can also use graphical user interfaces, but the shell remains a popular and flexible choice and an easy way to run script files. You can use shell commands to perform tasks such as moving and copying files, writing to and reading from files, extracting and filtering data, and searching for data. There are many shell versions, but the base functionality of most is the same. Some popular examples include Bash and Zesh. You interact with the Linux shell through a Linux terminal. A terminal is an application or user interface where you enter the commands you want to run and receive any output from those commands. For example, to start the Python application and run a program called myprogram.py, type Python space myprogram.py. When you press enter, the shell runs the command. This program prints the words "Hello World" to the terminal. So how are commands run? First, we have a user who wants to run a command. They enter the command in a terminal, which is then relayed to the shell. The core components of the operating system and kernel translate the command for the hardware to perform. When the hardware completes the command, the kernel reads any changes or results and sends them back via the shell to the terminal for the user's information. The terminal is a powerful way to run applications and interact with your machine. Now, most terminals have a similar user interface for you to enter commands. The area where you enter commands is called the command line, and the vertical line, or cursor, is the command prompt. This indicates where the text that you type will be displayed. In this example, the current working directory is the Documents directory, which is inside the Me directory, which is inside the Home directory. The current working directory is the location where the shell will look for any commands that you specify to run. For example, the Python program in the previous example. Not all terminals display the full location or path of your current directory, so some will just display documents here. The path is the human-readable location of a directory or file in the Linux file system. The A/B structure indicates that the file or directory named B is located inside the directory named A. There are also special paths. A single tilde symbol refers to the user's home directory. A single slash at the beginning of a path refers to the root directory. 2 periods refer to the parent of the current directory, and a single period refers to the current directory. So let's look at how you can use the terminal to change the current working directory. You use the cd command that stands for change directory. Enter cd/ to go to the root directory, and enter cd bin to move into the bin directory. The bin directory, which is inside root, contains programs required by the system. One of these programs, or executable files, is called ls. You can run the ls program in the current working directory by entering /ls. Use it to display in the terminal window the names of all files and directories within the current directory. Many commands located in the bin folder are also built into the shell, so you can run them from other locations too. Navigate to your home directory using cd tilde, and even though the current working directory /home/me does not contain the ls program, you can still run the command successfully. Let's look at some more examples. Again, starting at the /home directory, enter cd space ... to change the current working directory to the parent of the existing current working directory. So in this example, the parent of /home is / or the root directory. To then navigate to a USB drive called My USB Drive in the media directory, enter cd space /media /my USB drive. You can also navigate up and down the tree in one command. To navigate up to the media directory, then up to the root, enter cd space .. And then to navigate down to the Documents directory in the Me directory in the Home directory, enter /home/me/documents. Press Enter to submit the command and move to the Documents folder. Let's move up to the /home/me directory. Start the Python application and run a program in the /home/me directory called myprogram.py. This program returns a message to the terminal window. In this video, you learned that a Linux shell is an OS-level application that you can use to enter commands and view the output of those commands. You use a terminal to send. Welcome to creating and editing text files. After watching this video, you will be able to list popular text editors for Linux, describe a popular GUI-based text editor, and use command line editors to work with a file. You use text editors to write code in your Linux environment. There are many editors to choose from, and they can be grouped into two main categories: command line text editors and GUI text editors. Examples of command line text editors are GNU Nano, a small and friendly modeless text editor, VI, a traditional command line editor originally created for Unix, and Vim, a powerful mode-based command line editor based on VI. A popular GUI-based editor is gedit, which is the default editor from the GNOME environment. And Emacs is another text editor that is one of the oldest free open-source projects still under development. You can use Emacs in GUI mode or within a command line. gedit is a popular modern text editor that comes pre-installed on most Linux distros. It's designed as a general-purpose text editor, and in keeping with the philosophy of the GNOME project, it emphasizes simplicity and ease of use with a clean and simple GUI. gedit provides many features to enhance your text editing experience, including an integrated file browser, undo and redo functionality, search and replace functions with support for regular expressions in the search string, and extensibility using plugins from the gedit plugins package. The text editor uses syntax color coding to help you interpret and focus on different aspects of your code. GNU Nano is a command line text editor that provides undo and redo features, search and replace with support for regular expressions in the search string, syntax highlighting, automatic indentation of code, line numbering, line-by-line scrolling, and multiple buffers so you can work with many files at the same time. To open a text file in Nano, type nano followed by the file name to open. This opens a new text editor window in which you can edit the file. Here is what the Nano app looks like. The main area displays the text of the open file, which in this case is the source text from the Nano Wikipedia page. The cursor is currently located at the beginning of the file, but you can navigate within the text using the arrow keys, page up and down keys, or home and end keys. Any text you type is entered at the cursor. You can also delete text using the delete and backspace keys. Pressing enter starts a new line. At the bottom of the Nano window, there is a list of commands that you can use in the editor. To access the commands, simultaneously press Ctrl and the letter for the command. For example, to get help, press the Ctrl and G keys. Let's see how to use a few of the editing options. To search for a view of that new pane. Within the square brackets, you can see the most recently searched string, which here is 1999. Type the string you want to find, for example, HTTPS, and press Enter. The cursor moves to the first instance of the search string it finds after the current position of the cursor here. Nano supports many other editing features, which you will explore in one of the labs for this course. Now, Vim is a traditional and very powerful command line editor. It takes some time to get accustomed to how it works, but with some practice, your fingers will develop muscle memory to accomplish all of your text editing tasks at speed. Entering Vim at the command prompt opens the Vim app. You can also specify a file name to edit a new or existing file. Vim has two basic modes: insert mode, where you enter text, and command mode, where you do everything else. After you start a Vim session, press I to enter insert mode. Type some text, for example, some text, and press the escape key to exit insert mode and switch to command mode. And the text is written to the buffer at the current cursor location. Now you are back in command mode, and you can save your file with a file name using the "save" command, along with a file name such as example.txt. The buffer is written to the file, and a message is displayed showing the file name, that it is a new file, it has one line with 10 columns, and that it was successfully written. And now that your file already exists, you can use the more common "W" command to write any changes to the file. To quit your Vim session, enter "Q." And to quit and discard any changes made since the last write operation, include the bang or exclamation mark, as in :Q bang. This was an introduction to Vim, but there are many commands that you can use to navigate the text buffer and perform operations, such as searching, copying, pasting, and moving text around. You'll get to practice some of these commands in an upcoming lab. In this video, you learned that you can use a variety of command line or GUI-based text editors to work with your Linux code. gedit is a GUI-based editor that provides many features to simplify your work. GNU Nano is a command line editor that provides similar functions.
Uy, 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 uy. Shuni akrobatik kurdi aka, onasi mensin. Siz bor, ko'z ko'rsatadi aka. Ichki to'rma. Yo'q, 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 yo'q. Nega? Nega? Ichki to'rda qaytarib ko'rib o'tganda. Voy be, voy be. To'rt ekan bor.
yo'qda.
Hammani subjektiv fikri bor. Shunga qarab o'zini fikrini aytaveradi. Men subjektiv fikrim bo'yicha AJ'ga ancha zo'r. Ko'p vaqt. Bu self driving car haqiqiy machine learningning eng zo'r natijasi taxminimcha.
Qiziq. O'zingiz qiziqib ko'rmadingizmi? Shu machine learning o'rganib deganda.
Ko'rdim pandemiya vaqtida. 10 tacha kurs oldim deep learningni. Courseradan deep learning. Shu bilan keyin to'xtab qoldi.
Shu mavzuda gaplashmoqchi edim. Biz eslayman, shu universitet paytlarida dasturlashni o'rganayotgan paytimizda learning curve'imiz juda baland edi-da. Hozir esa kim bilan gaplashmay, o'zim ham shundan qiyos. Kim bilan gaplashmay, hech kim qanaqadir texnologiyani aktiv o'rgangani yo'q. O'zini ishini qilyapti, qo'lidan ko'p ish keladi, chunki oxirgi 7 yil, 8 yil davomida ko'p narsa o'rganib qo'ygan. Ozgina komfort zonaga kirib qoldikmi deb o'ylayman-da. Nima deysiz?
Shunaqa, aniq.
Bu yaxshi deb o'ylaysizmi yo yomonmi yoki biz qaytishimiz kerak, o'sha learning curve qaytarishimiz kerak deb o'ylaysizmi?
O'rganib tursa yaxshi. Endi men taxminimcha atrofimda biladiganlarim hamma tekda ishlayotganlar nimaga unaqa komfort zonaga chiqib qoladi, qaysidir leveldan keyin, qaysidir vaqtdan keyin prioritylar change bo'ladi vaqt o'tishi bilan.
Hayotdagilar.
Hayotdagi boshida o'qish edi priority, to'g'rimi? Qancha ko'p bo'lsam shuncha yaxshi. Consume qilishim kerak edi. Hozir meni ko'proq priority'm production. Produce more, consume less.
Bu yerda
ya'ni bu degani news kamroq consume qil, YouTube video kamroq consume qil, kitob o'qish bo'lsa ham kamroq consume qil, ko'proq productionga e'tibor ber.
Production deganda nimani nazarda tutyapsiz? Ishda qiladigan ishingiz,
Outputingiz ko'proq bo'lsin.
Outputingiz. Ishdan tashqari narsalarni ham nazarda tutyapsizmi?
Hammasi, ishdan tashqari ham.
Oila qurish, ular ham kirib ketadimi?
Masalan, o'sha yaxshi vaqt o'tkazish oila bilan. Bittasi shu prioritylar change'dan bittasi consume less, produce more bo'lgan bo'lsa, keyingisi oilaga vaqt ajratish kerak. Oldin 24 soat meniki bo'lsa, endi 8 soatni ishga berdim. Yana 5-6 soat bolalarim, oilam bilan 8 soat uxlashim kerak. O'rganishga vaqt kamroq qoladi. Keyin o'sha qolgan qismini ham yana consume qilishga emas, produce qilishga vaqt sarflagim keladi. Bir qiziq gap o'qib qoldim qanchadir. Consume less, produce more, doesn't matter what it is, doesn't matter if it's bad.
Yeah, just do more.
Just do more. Output more.
Menga shuna tuyuladi, deylik 7 yil 8 yil davomida consume qilgan bo'lsak, o'sha bor bilim bilan undan keyin produce qilyapmiz. O'sha bilimlarni asosiga, ustiga qurilgan odammiz-da biz va qo'limizdan kelganicha ishlab chiqaryapmiz nima bo'lsa ham-da. Bu qanaqadir sekinlashga nima deydi, olib bormas mumkin. Ya'ni 7 yil 8 yil davomida olingan bilimni yangilab turish kerakmikin deyman-da, tezroq.
Ishda o'rganasiz. Masalan, faqat bir xil ish qilmaymiz-ku. Har doim yangi problemalar, yangi sohalar, yangi featurelar, to'g'rimi? Yangi proyektlar. Bu technical tomoni. Communication o'rganamiz, lead qilish o'rganamiz, organize qilish o'rganamiz.
Balkim menga shunaqa tuyuladigan sababi o'sha paytda biz o'rganadigan narsalarimiz ITning atrofida asosan bo'lgan. O'ylaymanki, hozir ham o'rganyapmiz ko'p narsa, prosta ITdan
Welcome to Installing Software and Updates. After watching this video, you will be able to describe packages and package managers, differentiate between packages for Deb and RPM-based distros, use a package manager to install updates, and use the package manager to install software. Both software updates and software installation files for Linux operating systems are distributed in files known as packages. These packages are archive files containing the required components for either installing new software or updating existing software. You use package managers to manage the download and installation of packages. Different Linux distros provide different package managers. Some are GUI-based and some are command line tools. Deb and RPM packages are used by package managers in Linux operating systems. They are distinct file types containing software or updates for different Linux operating systems. .deb files are used for Debian-based distributions such as Debian, Ubuntu, and Mint. Deb stands for Debian. And .rpm files are used for Red Hat-based distributions such as CentOS, Red Hat Enterprise Linux, Fedora, and OpenSUSE. RPM stands for Red Hat Package Manager. Deb and RPM formats are equivalent, so the contents of the file can be used on other types of Linux OSs. If you find that a package that you want to use is only available in the other format, you can convert it using the alien tool. To convert packages from RPM format to Deb, simply use the alien command and specify the package name that you want to convert. To convert to RPM format, use the rswitch with the alien command. Package managers provide several benefits. They can automatically resolve dependencies between packages. They can notify you when updates are available. GUI-based package managers can automatically check for security and software updates on a regular basis. And they can automatically install updates or let you select and install just the ones you want. GUI-based Linux distro package managers include PackageKit and Update Manager. Update Manager is a GUI tool for updating Deb-based Linux systems. By default, Update Manager checks for software updates daily and automatically downloads and installs any security updates daily. All other updates are displayed weekly. You can also manually check for updates at any time. Update Manager will notify you when software updates are available. Select the updates you want to install, click Install Updates. If prompted, enter your user password and click OK. And Update Manager installs the updates in the background while you continue working. apt is a command line tool for updating Deb-based Linux systems. You use sudo apt update command to find available packages for your distro. The output for this command lists each available package, builds a dependency tree, and lets you know how many packages can be upgraded. To upgrade all installed packages on a system, use the sudo apt upgrade command. If you want to only install a specific package, you can use sudo apt install package name. Package Kit is a GUI tool for updating RPM-based Linux systems. When updates are available, Package Kit displays a starburst icon in the notification area. It automatically checks for updates at a configurable interval, and you can also manually check for them at any time. Clicking the starburst icon opens the software update window, which lists all available software updates. Select the updates you want to install, and then click Install Updates. If requested, enter your password and click OK, and Package Kit installs the updates in the background while you continue working. Yum is a command line tool for updating RPM-based systems. Yum stands for Yellow Dog Updater Modified. To update all packages in your system, type sudo yum update. After you enter your password, Yum fetches all available package updates, and then it displays a summary of the updates and asks you to confirm the download. If confirmed, Yum downloads all the package updates and updates the packages on your system. And when finished, it displays the success message, complete. You can also use command line tools to install new software. Use the apt command with the install switch to install a package on a Deb-based system, and use the yum command with the install switch to install software on an RPM-based system. Many software applications use package managers, such as the popular pip or conda packages, for managing Python environments. For example, assuming you already have a Python environment and the relevant pip package, you can easily install the popular pandas library used for data wrangling in Python. Enter pip install pandas to instruct the pip package manager to search for the latest pandas package, download the pandas package, check for dependencies and update as required, and install the pandas package. When the installation is complete, the package manager displays the new software version number. In this video, you learned that .deb and .rpm are distinct file types used by package managers in Linux operating systems. Deb and RPM formats can be converted from one to the other. Update Manager and Package Kit are popular GUI-based package managers used in Deb and RPM-based distros, respectively. And apt and yum are popular command line package managers used in Deb and RPM-based distros, respectively.
Alo. Alaykum assalom, yaxshimisiz?